Hi, Robin here. This is one of several short videos explaining the basics of SEM, that is structural equation modelling. I'm trying to look at structural equation modelling as an alternative to carrying out basic statistical tests. We've looked at correlation, and now we're going to look at the two independent samples t-test. So there's actually three approaches, you could say, to developing the two independent samples t-test as a structural equation modelling. The first one is a multi-group approach. The second one is using regression, using indicators. And the third one is really a rehash of the multi-group approach, but using the Onyx particular way of coding, which makes life a lot easier. So before we actually do this in SEM, in Onyx, we're going to actually carry out the analysis very quickly in R. Don't worry if you don't know R, I just want to get basically the p-values and the other associated statistics so we can compare. Remember, on my website, as I show here, you can download all the software you require, the handout I'm working from, and the data sets. So here is the R console, and we're going to just carry on working with the same set of data we did in the previous session. So first of all, it's always a good idea to decide which variables you're going to use and what you're going to do with them. Well, we need two variables that are suitable for independent samples t-test, so we're going to look at the age distribution across the two schools in that sample. So we just always a good idea to do a box plot when you've got several groups of data. And there we are. We can see that for the Grant White school, it looks like the average age is exactly the same as for the Pasteur school, except they look like there are a few more older pupils and a few more younger pupils in the Grant White school. So probably we won't get a highly significant p-value, but I might be wrong. Right, let's carry out a t-test in R now to get our probability value and various other things, so we can use this to compare to what we get in the SEM model. Here we are, we get a t-value of minus 4.4, a p-value of 1.498 to the minus 5. That basically means 0.000014. A very small p-value, so I was wrong there. We can see what the sample means are for each group there, 12.7 versus 13.2. When we've got 300 in the group, and probably the standard deviation isn't that great, so that's probably why it's such a significant value. The t-test is basically an ANOVA with just two groups, so we'll carry out one-way ANOVA as well, because it will give some idea about the relationship between the two quickly. You'll notice there that the t-value is minus 4.4 and the f-value is 19. Actually, if you square 4.4 you get the 19. Also, the p-value is exactly the same, you notice. It's quite nice to get the sums of squares as well. You do that in R using a two-step approach, because you can't get it straight away. So first of all there I just run the ANOVA, and then I ask for the ANOVA table from that. And we can see there that we've got a sum of squares for the actual schools and a sum of squares for the residuals. There's also an R squared value, and if we're going to consider SEM modelling, we're probably going to end up with doing some type of regression, as I said at the top there. So it'd be quite nice to do a regression on this, which you can do, and that produces the regression R squared, because that's the only value I'm really interested in here. So you can see the R squared value is 0.06, which means that 6% of the variance in our data is accounted for by the model. A very small amount, really. And just out of interest, you can realise that r squared value can actually get the actual r value. You can see there it's 0.245. So if you squared that, you'd end up with the r squared value. Right, now let's get on with carrying out the equivalent model in Onyx. To run Onyx, basically downloaded it as we did in the previous session, and now we need to actually find the file again, which is in my softwares directory. There we are, and you can see there's an Onyx file. Double click on that, the Onyx window appears. You can get rid of the tip of the day, which we don't want. We can also make the window the right size, so it jumps back into the corner again, and back we are to where we want to be. And now we get the data. Because we're working with two independent samples, what I've done is actually put the data for each school in two different files. And we can work around this. This is the nice trick that Onyx gives us, but we'll work on that after we've done it the usual way, with actually having them in two separate columns. So now we look at the data, and the data is, you can download from my site, and there's two files, and they are called HES data Grant School and HES data Pasteur School, and you can choose them both together and drag them onto the Onyx window. Remember, we can only drag these data windows from the bottom, so you have to get to the bottom. There we are. Now we want to create our new model, so right mouse click on the canvas and choose Create New Model, Create Empty Model. And there is our model panel. Right, so what we've got to do now is drag the data. Now this shows you how intelligent, how stupid the software is, because what it's done is realised that we've got two variables in different columns with the same name. So if we look over here, we can actually just see that the standard deviation for the first one is 0.96, and the standard deviation for the next one is 1.5. And yet, even with all them working out the squared values each other, as we see here, we've got the variance is the same. That is because they think it's the same. We want to treat it as the same column because it's given the same name. So what we can do is click on there, then right click and change the name. So we change the name for this one to G underscore, and this one P underscore. Just be fussy. There we are. And now you can see they reflect what we actually have in the two separate columns. Now we're going to actually add another type of error we haven't come across before, called a constant. And basically this allows us to model mean values, because remember what we're interested in here is means, so we actually need a way of specifying a mean value. So we drag that to our indicator variable, and then we say a free parameter, and we do the same again for this one. Create variable, and it's a constant again. And let it freely estimate, so we get the mean value there. So you'll notice here that we have a constant going to each our indicator variables, and you'll notice that they're not joined, these two. And if you go up here, it gives us a warning. It says multiple data sets without identifier column are used. These will be treated as independent. which is exactly what we want. We want to class this as an independent samples t-test. So if we actually look at the values here, by going to the window, show estimate summary, we'll see chi-square is 0, chi-square is 0 because they're independent volume models, so we've got nothing to compare them with. And you will see I get exactly the same values of these if I change this to a latent variable. So remove that, we'll get rid of that. And we create two latent variables. So create variable latent, drag to there. Now, latent variable, remember you have to be able to identify it. You can either identify it by the path, allow to vary, or the variance. Different people have different views. I'm actually going to fix the variance to 1 and allow the path to vary. And I'll do exactly the same here for this one. So create variable, latent, drag to our indicate a manifest variable, set variance to 1, fix, and allow that to vary. And if you remember, now we have exactly the same values estimated as before, and in our estimation column, which we'll see we've got this star here saying there's new results available. So we click there on estimation and choose show best maximum likelihood estimate, which we'll do. There is. You can update the script. Sometimes you need to update it, it does it automatically. And we can see it's exactly the same as before. Right, now what we want to do is what we normally do in our t-test, is actually compare this against a null model. So now we've got to change this to a null model, and that's very easy. What we need to do is actually save this model first. Rather than last time I didn't bother to give it a name, I'll give it a name this time and call this one the observer. Means. Right, so we call this the observed means. Then we right click on the model, go to edit, and we choose clone model. Now we've got a second model here. Now we've got to be very careful because of all these names that we don't want to be the same, else we'll end up with it thinking it's the same value between our models. So we've got an x1 there and x1 there. We'll call this x1, we'll just call it xx1, and we call this xx2, we'll call this g underscore ap2, we didn't need to change these names because I changed them when I dragged them over, so this isn't really necessary, but still. P underscore ag2. Right, there we are. Now in this null model we want to make these two means equal, and we do that a very nifty way in Onyx. We just give it a name and make sure it's the same name for each one. So you could call this tote mean, make sure we click there. Yes, we did. Yep. And now if you notice, they're both equal to 12.97, which is the overall mean of both samples. So if we look at the summaries of results from both of these models, go to show estimate summary. That's for that model. We'll put it at that side. And then if we click at this one and say show estimate summary, and put it at this side, we can compare. We see that there's little difference really. The -2 log likelihood 859 for our model with 2 different means, and the model for where they've got a pooled mean is 878, slightly higher. We can also look at these other measures. There's a AIC and a BIC, which means better fit in models have lower values. So we've got 867 there compared to 884. So the model again with 2 different means compared to the pooled mean is better fit. Right, we will now actually compare these two -2 log likelihoods using our usual graphical technique. So we close both these scripts by right clicking on them, then clicking close script. We've got some more values there just come in, so it's always good using to say estimation, show best estimate, and again right mouse click on one and drag to the other. And there we have our little line. If we go on top of it, we can see there we've got a p-value of 1.37 to the -5, which is identical to the p-value we got from the independent samples t-test. Just out of interest, you can also draw these means they're the same value. We could have actually just had one. So get rid of that. There we are. And just make sure we call that total mean as well. And you'll see it's recalculated the values. That's my best value. If we look at our comparator again, it will be exactly the same as before. There we are. That is one way of creating the equivalent to the 2 independent samples t-test in an SEM environment. Now we will look at how we can do this a little easier using multigroup modeling in Onyx. Instead of using this set of data, close the data sets. We'll go back to our original data set. We had the values in one column with an identifier column. There we are. I'm just going to remove these latent variables, replace them with the variances for the observed variables. It doesn't make any difference, but conceptually to me it looks a bit better. So now I've replaced the latent variables with the variances, the observed variables. So we just check to see that we haven't got anything joined to anything accidentally. Now we've got to choose the values again, and this time remember it was just the age we're using here, and we just go to age, which is that variable, drag it across there. So now we've added our new variable, our new data to that variable. We've got to tell it a particular subset of data we want for that particular school, and to do that we use in Onyx this very clever technique called multigroup modeling. I'll just show you what's going to happen. You'll see that I've got in the data set another column called school, and the column called school has just got a set of 1s and 2s. 1s represent one school and 2s represent another, so we can use that as a grouping variable for our age variable, and we'll do that now. So we click on the variable and then say add grouping. Once we've done that, little diamond appears here. Then when we go back to right clicking on the variable, we see we've got a group identifier it's asking for. So we know that's 1, or it could be 2. I'm not sure which way round it is. I think it's 1 for the first group. And then we do exactly the same here. Add grouping. And we've got to let it know which variable it is. It's a school again. And we say 2. And we've got to actually say we've let that one link to that, and now we've got to let this one link to that as well. We just drag that there. Again, I'm just going to change the names so I know which one's which. First one's G, and the second one's Pasteur School. So now we have a setup where we've used the same column for both independent variables in the model. I have to do exactly the same here, but in the end I get the same result as I did before. I just thought I'd show you how to use grouping variables because they're very useful. It means you don't have to manipulate the data to put each subset of data you want that's independent in the model as a separate column. You can just use this grouping variable, which is brilliant. We will now look at the t-test as a regression. So I will close the model windows. I'm not going to bother to save them. Now, to carry out an independent samples t-test as a regression, we've got to be careful. First of all, we create a new model window. There we are. We could carry on using our data set here, but if you remember, I said that school I've coded as 1 on 2s, and if we put that as a predictor value, Onyx and generally SEM software wouldn't know that that was just a code. They would think it was a value of some variety, a real value. So what we're going to do is use another data set where I've created 2 columns. And these 2 columns basically have what's known as indicator values. So the first column has a set of 1s and then 0s, and the next column has a set of 0s and then 1s, and there's no overlapping. So that represents school A and that represents school B. So we'll begin. We'll get this upper data set. First of all, close that. The set of data we need with these 2 extra columns is called hs.data_indicators, and again you can download it from the web page on the website. What we're going to do is consider the indicator variable, each of them as a separate input variable to the regression, and in the output it's going to be the age. So the age is there. We'll put that to the right. I always think of regression equations as going from the left to the right, which is probably the wrong way round, but still. Right, so there we are. That's our output, a dependent variable, and the 2 independent variables are going to be the Pasteur and the gram right indicators. And we can see here we have school code and school code 2. School code 1 there, and school code 2 is there, and we can give them sensible names. School code 1 we'll call Grant White, school code 2 we'll call Pasteur. And now what we want to do is regress each of these onto our outcome variable. So click on there, right mouse click and drag, and then we say free parameter. Similarly, click on there, drag and say free parameter. So now we have two predictors, two indicator predictors for this one output. Now if you remember, in regression we talked about before, we allow the output variable to actually only have two aspects to it: the predicted values, and then the alpha value is this latent score, the residual. So we create the residual score, which is called the latent variable. So click on there, drag towards it, and again set its variance to 1, and allow every residual to be freely estimated. Now what we want to do is actually see mean values rather than it centering these variables and not considering the means in detail. So to do that, again we add our constant and we select the two variables. There we are. And now we can see 13.2 and 12.72, which for the means of each of our groups. Also, we can actually, remember, click on here, customize path, show standardized score. That will be the beta weight, and we get the same beta weight for here as well. If that's a model of our observed data, now we've got to create a regression model that is for the null model when there's no difference between the two. And again, we do it very simply, we just make those two regression lines equal. Again, we'll save this model and call it observed. Edit, clone model. That's our cloned model. You can drag all the objects together if you left mouse click and then lasso them and drag them up there. That's it. Right, so now we've got to make this window a bit bigger so we can actually get to them. Right, so we want to make these two regression lines equal. You'll notice that the model I cloned, you can see from the data window it cloned the variables as well, so we don't have to relink them. Right, so to make these two regression lines equal, we'll just say, call them shared. They've both got the same name. Now we see they're both equal, and now we can compare the two models in our usual way. Drag, and we see 1.46 to the -5 again, exactly the same as before. So what we've done here is create an indicator variable and then use that to create a regression, and that gives us exactly the same value as we had before. So we've managed to carry out an independent samples t-test using 3 different approaches to modelling in SEM. We go back to our original list. We created a multi-group approach to it. If you remember, there were two called manifest variables, our variables, the square boxes, and then we had the variances, and then we had the means, but we didn't have them joined together, they were totally independent. Then we used the regression approach with indicators, and we also, when we were doing the multigroup approach, we used the Onyx approach, setting up a grouping variable. So the next thing we're going to be looking at is the paired samples t-test. Bye for now.